and welcome to Climate Chat. I'm your host, Dan Miller, with my co-host, Leon Simons, who just returned from some travels, and so did I. So we're actually both home now for the first time in a while. And today we're going to be talking about a bunch of things, including what's been going on very recently with extreme heat and fires and smoke, which I experienced actually on my trip, and Leon had some experience too. And we're also going to talk about Jim Hansen's latest communication about how hot it's going to be this year and next year and what's driving that. So with that, I'm going to turn it over to Leon to kick us off. Welcome, Leon.
Hi, Dan. Welcome home to you, to your home. And indeed, we just got back 2 days ago from a 24-hour travels all the way back from Ethiopia, where I was commemorating my brother's passing 10 years ago with my family. And we also went to Ethiopia, where I worked for 10 years, also to show my family, my young kids, and my wife. So, yeah, let's get started. Share my screen. Sorry.
Go ahead.
Yeah, so there we are. So just the beginning. Yeah, I think that's unfortunately quite an appropriate title to today's climate chat about global heat and local extremes. And before we started to travel in June, there was in Europe there was a heat wave as well. It was very hot here, and it will be very hot coming days as well in the Netherlands. But it also, let me show you, it's of course very regional, but we also got a big hailstorms on our farm with a lot of holes in the roofs, and luckily our solar panels didn't get destroyed. But this does make me a bit anxious about our energy system of the future, because here are some dead swallows that fell from the nest inside the barn. It's a different barn where the roof didn't get destroyed, but yeah, a bit anecdotal maybe, but we're starting to feel the heat here in Europe more and more, and that you see that of course in temperatures, but you also see that in increased weather extremes, which we don't normally experience or very rarely experience. And I want to go to talk a bit about the El Nino. And here I decided to share this graph from someone called Indonesische Bergwiese. I think that's German, but what I really like about this graph is it really visualizes how strong this El Nino already is. It's already, as you see here, at 2.5 degrees temperature, degrees Celsius or Kelvin, which is the same, above the anomaly. And that's the Ocean Nino Index, which keeps changing for every year. They use the 30-year average from every 5 years that period changes. Now we use more and more. You see the relative El Nino, but here this is the Oceanic Nino Index, and this is from 1995, I think, to 2006, to 2005, so 30 years, or sorry, 1996 to 2025. This is the anomaly. You see, it's really now at 2.5 degrees above, so already well in the super El Nino territory, much sooner than ever before. And this might shift a bit when the temperatures get shifted with the new 30-year baseline. That's why the relative El Nino is in many ways better to use, but it does give an indication. And I shared this from a Twitter or expose, because I really appreciate how many people, I don't know if this person is a scientist, but everyone who can access the data and can work with the data can make their own graphs and do data visualization. And I really recommend everyone who can do that to try it out and to look at the actual data. And if programming isn't your thing, you can also just go to the website of climatereanalyzer.org, and you can see the data as well. You can download it to make an Excel sheet, or you can just use the interactive web app or web program and look at the data. And funnily enough, because this is the 1991 to 2020 baseline, it's a bit lower. So the temperature of the region decreased. If you take the new 30-year period, there was seemingly some cooling, and of course that's because there were more La Niñas or less El Niños. And so you have to take that into account to understand the small differences in these anomalies. But also then, if you use this, it's already well in super El Nino territory. Mm-hmm. And I want to show you this as well, where Adam McKay's team with Yellow Dot Studios, which he founded to make people more aware of climate change and what to do about it.
I should mention that we interviewed Adam McKay a year or two ago, and if you're interested in hearing that, I think it's called "Is Climate Change Funny?" Because he takes a different approach to talking about social issues, and usually with humor as part of what he does. Adam McKay is the one who produced and directed film "Don't Look Up," The Big Short, and many others. Well-known filmmaker, and go check that out if you missed that show from a year or two ago. Check it out on Climate Chat.
Early July, Stacy, 2024. Okay. Yeah, you can find it on Climate Chat, Adam McKay, if you look it up. Thank you, Dan. Yeah, and they raised the alarm, and I also signed this letter, and everyone can sign this letter to ask the governments from countries and regions to get their shit together in many ways, right? And to prepare us for this very strong El Nino, because what we are experiencing now isn't really El Nino yet, because it takes a few months for these impacts to materialize. And also Europe isn't impacted normally much by El Nino. It's impacted by many things, we'll get to that, but not very much by El Nino. So I think, everyone should sign this letter, because you cannot cope by yourself with these extreme weather impacts that are coming the coming year. So you really need to get your government officials, demand them to do that for you, to prepare the countries, and also global cooperation, because of course many people will suffer who are not in wealthy countries, and they also need assistance.
But as the title of this program is just the beginning, global heat and local extremes. So I think it's important to point out that however hot it gets this year and next year, and we're going to talk a little bit more about that later, but in 10 or 20 years, we'll be looking at this as the cool, good old days. In other words, there's only one direction. I mean, it fluctuates up and down, especially because of El Nino and La Nina. So year to year, we certainly can have fluctuations. But decade to decade, it doesn't fluctuate. This is the coolest decade forevermore. As bad as you think it is, it's the coolest decade forevermore, unless we do SRM and other things. But so this is really serious. And to be honest, I mean, society has not been paying attention to this very much, and it's getting woken up. But even with what's happening, I think people see it as a one-off kind of crazy thing, and don't realize that this is really just the beginning.
Yeah, it's wishful thinking. And then we have the Mediterranean, which flew over. I'll get to that, but it's again from Indonesia's Bergweser. Now that the month is over, it's time to look at some regional sea surface temperature series. The Mediterranean had its warmest July on record with a 2 °C anomaly, 2.1, above again 1991 to 2020. And computer says as an acceleration.
Is there a what year did the IMO kick in? That was just last year, right?
Yeah. So of course you have that's a question about the impact of reduced sulfur emissions, and you asked me before, and I'll get to that now. But so in 2020, the global sulfur regulation came into effect from the International Maritime Organization on January 1st, and then the sulfur emissions from global shipping reduced, and also over the Mediterranean, by about 80%. The maximum sulfur fuel content decreased from 3.5 to 1.5%. And on May 1st, 2025, we saw another decrease of about 80% of the maximum sulfur fuel, the maximum amount of sulfur that may be in the fuel that is burned by these ships, unless they use scrubbers that wash out the sulfur and dump it into the ocean. From 0.5% to 0.1%. So that's an 80% decrease, and maybe even more depending on what fuel they use. So you see now already, and of course there's also other emissions around the Mediterranean that are decreasing. Countries around the Mediterranean, like Italy, but I think there's 18 or so, 12 or 18, I don't know it by heart, but there are a lot of countries around the Mediterranean which are and will be impacted by this increased rate of, already by the rate of warming of the Mediterranean, which is very high, but also the rates increasing. So it will be impacted faster and faster. And of course, with also the impacts are not linear with temperature increase. So because of that, we will see more and more impacts. So and countries like, of course, Italy and Spain and Portugal, but also Greece and Turkey, they have rapidly reduced their sulfur emissions also from coal plants, for example. Also, Turkey wants to be part of the EU in the future, and of course, clean air is also one of the things they have to work on if they want to become a member.
It's probably worth summarizing that the burning of fossil fuels creates sulfur compounds, and that pollution, along with other fossil fuel pollution, kills about 8 million people a year. So it's a really huge health impact, mostly in China and India, but all over the world, the United States and the EU as well. Hundreds of thousands of people die. It's not listed as fossil fuel pollution. It's listed as heart disease or lung cancer or whatever it might be. But there's a Harvard medical school study that relates all of this. And so as we clean that up, that same deadly pollution has also been reflecting the sun away and cooling the earth by a lot, 0.5 to 1 degree of cooling from our accidental SRM that we're doing. And what you're saying, as Europe especially was good at cleaning it up. And this kind of cooling, by the way, is more regional. It's like where you pollute, the pollution is near you, and that reflects the sun near you and cools you locally or regionally.
Yeah.
And so you're saying as you clean it up, it's been getting hotter. I also note that there's a spike in the middle there, and I was thinking, what is that? That's around the time of the 2003 heat wave in Europe that killed more than 50,000 people. So maybe it's related to that heat wave.
Yeah.
Okay.
Yeah, of course, like hot Mediterranean, and if you have the heat coming from the south, then that adds to the heat of the whole of Europe. But I haven't looked at these different spikes yet. It's a good question to ask. Of course, if you have a spike like this on top of this, right, you can imagine.
Pretty crazy.
Yeah, so above the trend. So even this spike, it's record high, but it could be worse, right?
I see an acceleration in that line there. That's not a straight line.
Exactly. That's what he says. Also, my AutoFit function shows a quadratic trend based on the Bayesian information criterion. So, what does this complex sentence mean? As I said, the computer says there's acceleration happening here. And of course, that also translates to extreme temperatures. Right? Bordeaux in France has now recorded more days above 40 degrees in 2026 alone. So already, of course, August has just started. August hadn't even started when he posted this. Neil Bergers, I don't know how you pronounce it, sorry. During the entire 105-year period from 1920. Already, that's quite crazy. Deeply shocking, termination shocking, as we can call it. Okay, now I want to show the video then.
Okay, here we go. This is.
We don't do this often, so yeah, there we are. Okay, just play. So what we see here, and I don't know if it will loop, but you see the month of July, and these are aerosols mainly from smoke, and you see there from this Europe, and then you see from the top right corner, it's going a bit faster than I can speak now, but here starting again, look at the top and also to the right, and then so see from the top left, from the northwest, there's all the smoke coming from the Canadian fires burning. But now if you look at Europe, there you see also that there are a lot of fires burning over Europe in France and in Spain, and might also be some fires burning there in the boreal forest of Russia. So I think this is the most burned area in Europe in July ever. And Canada, of course, 2023 was really extreme, so we might not hit that with Canada this year, but maybe we will. And if you ask, and you asked it before, it's like, what is the impact of this reduced air pollution on the Mediterranean? This, of course, this makes it very complex, right? You have all these fires burning, and they also reflect sunlight, and they also provide these aerosols, which are cloud condensation nuclei, which make clouds form bigger and brighter, maybe longer living as well. And you have many of these smaller droplets, so the clouds change. And if you ask the IPCC, if you look at the IPCC methodology, they assume, of course, that the CO2 is emitted here is natural because these forests grow and they take up CO2, and then the CO2 is released. So this is a natural release of CO2 that doesn't add to the carbon budget. And we've spoken about this before. But if you look at this air pollution, so the particulates, this is frankly put, this is all there's all arson. This is all arson. So these fires have been lit, and it's all anthropogenic. It's all human aerosols, and then they put this into these simple models, and with that they hide the reduction, because you have increased forest fires because of warming, because of drying, because of more sunlight reaching the trees and drying, and because of fertilization from CO2. So, and of course, where there's fire, there's incomplete combustion of carbohydrates, right? So that's all. That all adds to the increase in how much fires are burned and how much natural, but according to the IPCC methodology, anthropogenic aerosols are in the air. And then if you assume that these aerosols from these forest fires around the world are man-made, and you just put them in the same basket as all these decreasing sulfur emissions, then your model doesn't think that there's such a big reduction in aerosol cooling, and then that translates to the reduction in the rate of warming, because they also in these update these papers these indicators every year. Many leading climate scientists go after these papers led by Forster et al. They present them as an IPCC sort of update, IPCC methodology update. But then, and they present the rate of warming, but they use these simple models which don't take these things, which even from if you would ask anyone, right, should you count the CO2 emissions the same as these aerosols, if they even understand it, or everyone would say you should either say they are both anthropogenic or both natural, but that's not what's being done. So that's also part of why the United Nations, as a recent paper by James Hansen and his colleagues, said that the United Nations is not well informed, because these indicators papers also every year present to the United Nations, UNFCCC, UNFCCC in Bonn. So they are not being well informed about what's really happening. So okay. That's global. Now back to my presentation.
Do you have more slides?
Yeah, a few more.
Okay, there you go.
So this was me flying from Addis Ababa, from Ethiopia to Brussels. If you see from a window, you see the moon, but here you can see all this smoke, and it's really hard to know what's inside this air, right? It's not normal clouds. You see that there's a big haze, but is it Canadian smoke? Is it Spanish smoke? Is it smoke from Portugal, or maybe from North of Africa, or is it Sahara dust, or is it smoke from France? That's really hard to tell. Or is it some pollution from the ships still, or is it some sea salt spray? Likely all of the above. And then still, it's hard to say how much of what is in there. So it's really hard. Like this is the biggest uncertainty within climate science, is how much cooling is caused by the reflection of this air pollution and the clouds that form because of it. Right? It's the biggest uncertainty within climate science.
I should tell everyone that just like CO2 is a cumulative problem, exposure to PM 2.5, the little particles in the smoke, they get in your lungs, and it's also cumulative. It's not like a one-day thing. You go out, you breathe, and then you get some fresh air later, and then you're all fine. Those particles are in your lungs, and they stay there. So point is, if you are in an area that's smoky and it's a bad air quality, if you go outside, wear a mask. Don't go outside and just think, well, I'm only going out for a little while, then I'll come back, the air will be clean. And also, you can get an air filter for your house. I actually tested that. We were in very smoky conditions from the Canadian fires in upstate New York. And I got a little air quality monitor, and I put it inside the house. It read 0, and I thought, oh, it's not working. And then we put it outside the house, and it gave the full reading, and you could see it very quickly. It went way up. So, and sister had an air filter, and so they really work, and use them if you're in such a conditions.
Yeah, I remember when my mother had this piece of land and she was building a fire, and I was already working in developing countries on clean cook stoves, and she was making a fire in this building that was there, and there was all this like smoke building there because she wasn't doing it properly for some reason, or the wood was wet and they have incomplete combustion. I'm not sure what was happening, but all the smoke was building, and I was like, Mom, get out of here, right? It's like it's really, really dangerous. This normally even just like smoke from a fire is like smoking like 20 packs of cigarettes, right?
Mm-hmm.
And then if you have all this smoke building in your room without ventilation, then it's even worse. And then after I left, and then she had a, I don't know what it's called, like a TIA. Is that the English word as well?
I didn't hear. What did you say?
TIA. TIA. What is it? Wait. Like a mini stroke.
Oh, yeah, TIA. we spell it out.
Yeah, TIA. You spell it out normally. We just do TIA. TIA. So she had, and she like passed out, and it's really dangerous, right? Because it's the smoke that, if you have a cigarette, of course, those are made to burn and inhale, but all these compounds that are in wood are can be extremely dangerous, and they can be gaseous, and then they can, because they're very hot, and then if you inhale them, they can form these clumps, and then you can clog your arteries, and you can get a stroke. So and then if your whole city or your whole country is covered in smoke, it's really dangerous.
Well, wear a mask if you have one.
Sorry?
Wear a mask if you have one there.
Yeah, I even felt like I could smell the fire when we were up there.
Yeah. Okay.
And I've shown this before, but I think and then I already talked about it a bit, so I won't elaborate too much. But this is from like a bit outdated. But if you see the main drivers of global warming, that's mainly greenhouse gases. Again, this is IPCC methodology. Mainly greenhouse gases already around 2014 caused 1.5 degrees of warming, with a big uncertainty. And uncertainty is mainly caused by the cooling effect of sulfur, which could have been up to that date up even as much as 1 degree Celsius. And this is again the sulfur emissions globally in 2010, very much over the oceans, but also over Europe, still a lot in 2010, still a lot over India and China and the US, and again, all these shipping tracks. And then if you reduce that sulfur, less sunlight is being reflected. There's another way, of course, it is the main region. Someone published a paper recently where they cited our paper, our 2023 paper, and misrepresented it by saying that we said there was a lot of warming because of the reduction in sulfur emissions over the tropical Atlantic, but of course it's mainly over the North Pacific and the North Atlantic where all this emissions, most of these shipping emissions happened. And then globally, you can see this enormous increase, and as we discussed many times here, it's not just aerosols, it's also warming and reduction in cloud cover and changes in where clouds are. But if you look at it, there's an enormous increase, and I have to update this graph. Again, I just got home. I think there's now 4 more months of data. But over 20 years, the global absorbed solar radiation over 510 trillion square meters of the Earth's surface, day and night average, is 2 watts per square meter. So that's really a mind-boggling number. And about half, and the energy imbalance increased over the same period. So how much heat accumulates globally in watts per square meter, and that's a joule per second, so a lot of energy every second. By about 1 watt per square meter. So, and it was about 0.4. So more than a doubling of how fast heat accumulates on our planet based on this NASA data. And also now more and more agreed by ocean heat content observations. And so the science is quite clear about that. No matter what some people say on social media or in newspapers, if the World Meteorological Organization is clear about it now. The scientists, and even some of the skeptical scientists who say publicly they think it's not happening. If you look, even if in the papers where the names are on, those show that the rate of global heat uptake, and with that the rate of warming, temperature increase globally, has significantly accelerated. And then Europe, it's even worse, right? This is, again, I should update this graph, but if you see sunshine duration, solar radiation, you see that that's from space. So there's a big decrease of about 30 watts. Let me see. Yeah, about 30 watts. Surface solar radiation is increasing. Cloud cover is decreasing. It's a bit not a great graph to show this, but because there's 3 axes. But yeah, the science is, if you look at it in detail, I recommend everyone who wants to understand what's happening and how it will change and keep happening, to look at the science, right? To look at the data, to look at the science. And then you see that, again, this study exacerbated summer European warming, not captured by climate models, neglecting long-term aerosol changes. And then summer warming in Europe underestimated by global and regional climate models by about 1 degree Celsius in this region. So if you don't take into account the reduction in aerosols, which regional models do not or barely do, depending on the model, you underestimate the regional warming in the summer by 1 degree Celsius already, based on observations.
So if I'm understanding this correctly, this upper left graph with the reddish one, that's the actual temperature. And then the one on the upper right is the temperature minus the modeled temperature. And it should be 0. It should be neutral color, but like white, but instead it's blue, saying that it's colder. So the actual temperature, the measured temperatures are about 1 degree higher than the modeled temperature.
Yeah, you misspoke. You said the observation minus the model, but it's the model minus the observations, which is a negative. So that's why it's blue.
Right.
It looks blue, but that means that the models are underestimating it.
Right.
The warming. And here it's even like Eastern Europe, it's much worse even. See, dark blue. I don't know why this study focuses on this region and not on this region, but maybe you had one
where the funding's coming from.
Or they want to publish another paper, I don't know. And this is regional, again, close to my house. We have 125 years of daily observations of very close to my house, one of the longest data sets on temperature and on sunlight reaching the surface in the world. This is in watts per square meter, so it's less long, but it's more or less the same. If you look from 1900, there was a bit of an increase and then a decrease until 1980. But now this summer, of course, the summer isn't over yet, but the estimate is that we'll have about close to the record highs, which were all in the past years, of sunlight reaching the surface this summer. And that's compared to the average in the 60s and 80s, 60s, 70s, and 80s. That's an increase of about 26 watts per square meter day and night average, a 24-hour average. That's really mind-boggling amount of additional heat reaching the surface here. And it's much the same, of course, over many other parts of the world. As I showed you, the global average is 2 since, what is it, since 2000. So here it's much more. And I think that's often missed in these discussions where when we talk about aerosols and about air pollution and reducing air pollution and what the impacts will be, many focus on the global average temperature, but nobody feels the global average temperature. We feel the regional impacts and the regional temperatures. And regionally, it's much worse. The strongest regional forcing is aerosols. And that's why we experience this. That's where in these rich countries where we didn't really feel the problem of all these greenhouse gas emissions because we were hiding the warming with air pollution.
Mm-hmm.
And many countries still are. India's as well. I'm now reading this book. It's Ministry of the Future. It's about India, many people have asked me if I've read it already, and now during my holidays I was finally able to start reading it. And yeah, I think it's even worse than this book. And in the book, it's really bad. But the problem, of course, is if India starts to reduce its air pollution, start to close its coal mines or start to desulfurize their coal mines, which they keep postponing, they will feel much more of the heat.
And they already feel a lot of it already. It's getting
they already touch degrees.
And yeah. Okay.
Yeah, I think that's, of course, like we could, and again, I recommend everyone to watch our conversation about this warning from the German meteorological organization and the physical organization, Gesellschafts, who put out this warning: global warming is accelerating, a call for decisive action, and that we could reach 3 degrees Celsius as early as 2050. So, and that's a global warming, not just for Europe. And we are now at about 1.5. So.
Very good. So is that the last of your slides?
Yeah, I can go on, but yes, it's the last one I had now.
So let's see, where are mine? I think it's here. So so I have some slides too, but it's sort of the same subject, but a little bit different. Climate scientist Jim Hansen, who's one of the best known climate scientists. He, along with Leon Simons, co-authored, along with some others, people, Global Warming in the Pipeline, which was one of really super important climate paper, one of the most important of the last 10 years, I think. And it talks about how the climate sensitivity is actually higher than what is assumed by the IPCC. And they assume it's about 3 degrees on average. And Jim says, no, there's 4 different ways we can tell it's about 4.5 degrees. They look at ice age temperatures. They look at the dimming of the earth. They look at the change in shipping was actually one way to tell by looking at how the temperature changed with the change in aerosols. And there was one other way, which I can't remember, model results or something.
Yeah, models, and of course, not just the last glacial period, but also the last warm period, Eemian. And
that's right. Looking way back too is another way. That's right.
Yeah. So and now also we write about looking at Venus, for example, at different planets, different climates.
So Jim just last week put out another communication. These are not peer-reviewed papers. These are just sort of like memos that he publishes more for the public and also just to explain the science to people in more plain language than a paper typically does. And so let's talk a little bit about that. But before we do that, one of my favorite quotes on climate change, which I think is very appropriate now because it's becoming more true. You may not be interested in climate change, but climate change is interested in you. This is a quote from Tom Friedman. It's a takeoff on you may not be interested in war, but war is interested in you. And I think we're getting to see what that all means now. And just to summarize, by the way, people look to the future, but let's take a look what's already happened. This is in the past. We've already increased CO2 in the atmosphere, humans, by 50%. It was 280, and now it's more than 420. And if you look at CO2e, CO2 equivalent, which includes methane and nitrous oxide and other greenhouse gases in addition to CO2, we've doubled the greenhouse gas forcing already. There's 75% less summer ice in the Arctic than there was 40 years ago. We're going to talk about this one as well. Extremely hot summers, which are defined as if you took a look at the period from 1951 to 1980, and you look at all the weather stations and you measure their average summer temperature, you get a little bell curve. And on the hot side, like in a particular place, it would be so hot that would only happen 1 in 1,000 times. That's what we're going to define as extremely hot summer for that particular place. So the question is how often, and that was 1951 to 1980. So the question is how often do extremely hot summers happen now? Not 1 in 1,000, but 1 in 5 times. And that means it's a 200-time increase or a 20,000% increase in extremely hot summers. The bottom line is when you increase averages a bit, like we've increased the global average temperature by 1.5 degrees Celsius, when you increase the averages a bit, the extremes go up a lot. And that includes rainfall and temperature and things like that. We've destabilized the jet stream already, which is making it slow and wavy, which is why we actually get cold waves, because Arctic air can now go lower than it used to be able to go and get to Texas, for example, and freeze them. And then the opposite happens where we get heat waves in Canada and things like that they've never experienced before. And this slide is from a long time ago. We're also going to get more intense heat waves, droughts, and floods and fires, and that we're getting all of those this last week. So that's just a little summary there. Oh, and I want to, before we get there, I just want to make this point again. We've mentioned it many, many times. But I think one of the reasons that society is not addressing climate change, because they know it's a problem of CO2, but they think of CO2 like all the other pollutants that we've dealt with in the past. Polluting a river with chemicals or something, you can clean up the chemicals, you can shut down the chemical plant, and then a year later, the water will be clean again. Take a look at China, where they had these coal plants spewing out sulfur particles you couldn't see across the street. And literally millions of people were dying every year from the pollution. They decided they didn't like that. So they put on sulfur scrubbers on their coal plants, just like the United States did in like the 1970s, 1980s. And they cleaned up that sulfur pollution. And now they still have bad air pollution, but not as bad as before. And now you can see across the street most of the time. And so we think that problems like this, hey, when we finally get tired of the bad thing, like we're tired of these fires and the heat waves, well, we'll then just cut our CO2. Yeah, we haven't done it yet, but when it gets bad, then we'll do it. But the problem is CO2 is not like those other pollutants. It lasts in the atmosphere for hundreds to thousands of years, so it doesn't go away when you stop emitting it. It just stops getting worse if you really stop altogether, and we don't have Earth feedbacks kick in that keeps spewing out greenhouse gases after we stop. So if we're lucky, it will stop getting worse, but it's not going to stop where it is now. It's going to stop, if we're lucky again, whenever we stop polluting. That would be like 2050, 2070, and it's going to be 3 degrees or more of warming, and it won't go down from there. unless, again, we do SRM and CDR. But we'll be stuck with that temperature for the next 1,000 years. And so it's really important to understand that CO2 is not like these other pollutants. And that's why you have to act now, and you can't wait till it gets so bad, because when it gets so bad that you finally want to do something about it, you're totally screwed. And we're kind of screwed now in the sense that we're already at 425 parts per million of CO2, plus other greenhouse gases. And we're seeing these things. We don't like what's happening, and yet we can't stop it again. We can if we do SRM and CDR, but we haven't chosen to do that yet. Anyway, I just want to make that point again. It's a simple point. I think it's the most important thing for people to understand about climate change, that this is not the same as the other kinds of pollution. We have models in our head of what pollution means, and this is a different kind. Think of it a little more like nuclear radiation. If you have like something that's radioactive on the ground, it has a half-life that's maybe thousands of years, and so it's just going to keep on going. It's that kind of thing. All right, let's see. So this is I mentioned before the graph about. Let's see if we can do this. Make this bigger here. So this is why this is a really important thing. This is why when you increase averages a little bit, the extremes go up a lot. So on the left, I'll do it up here. On the left side is the base period, 1951 to 1980. And basically, this is just taking every weather station in the world, and it's a thermometer measuring it. So this is not based on models. So this isn't a prediction. All of this stuff has already happened. And back then, if you measured the temperature in all those places and you run the statistics, you're going to get a bell curve. And you're going to say a third of the time the temperature was about average, a third of the time it was cooler than average, and a third of the time it was warmer than average. That makes a lot of sense, right? But these numbers down here are standard deviations. So if you get out to a 3, that's a 1 in 1,000 chance. And you'll see that it was that much or more, 3 standard deviations or more, 0.1% of the time, 1 in 1,000. So that makes sense. So it was 1 in 1,000. Now, with global warming, we shifted the curve. So the average temperature here, the average temperature has gone up. And now, in the last time they did it, it was 2010 to 2020. So it's even worse than this now, by the way, because we're in 2026. But looking at this last decade, the average temperature has gone up a little bit. And now the part that's more than 3 standard deviations. Oh, by the way, I forgot, I guess I didn't mention, this is the average summer temperature at each of these weather stations around the world. In this case, it's, I think, northern hemisphere. But if you look at globally, you have to switch summer. Globally for the southern hemisphere, the chart looks the same. And here we see it's now more than 3 standard deviations from before, and it's happening now 22%, more often than 1 in 5. And that's insane. That's a 22,000% increase in extremely hot summers. And these are real things. These are like what we're experiencing now in Europe is an extremely hot summer. It's not just a statistic. It gives you the droughts. It gives you the heat waves. It gives you the fires. And it's happening in extremely. And what the amazing thing to think about here, so that's 3 standard deviations is 1 in 1,000. I think 4 is like 1 in 10,000. 5 is, I don't know if it's 1 in 100,000. 6, 1 in a million. It's not exactly that, but it gives you a rough idea. I think 5 is 1 in a million. And those things never happened before. Like 1 in a million, never, ever happened before. And we are now seeing these 1 in a million things. Leon, the graph you showed of Bordeaux, France, with temperatures way above anything ever seen before.
Above 40 degrees.
That's an example of this. I mean, this is the average summer temperature, not daily temperatures, but you get the idea. It's some extreme thing. It was maybe a 1 in a million chance of ever happening before. And now 1 in a million might happen 1 every 50 or something like that. And again, and this is individual places. So you think it's not every 50 years you'll see it one time. You'll see it maybe every year somewhere, because there's many, many places for this to happen. It's just that the probability of this happening is, it's not a little bit higher. It's thousands, well, it's hundreds of times more probable of it happening. And I think when it comes to the 1 in a million, it's thousands of times more probable. So anyway, this is extremely important. This is explaining why we're seeing the crazy record-breaking things. The average temperature only went up 1.5 degrees, but we could see like I know Bordeaux went up, I forget how many degrees higher than average that was, but 10, 20 degrees above average or something, or even above the peak. It was a very big number. So anyway, there we go. That's a very important graph, I think. And let's get to here. Go forward. So this is a really cool graph. This one is kind of hard to visualize here. But what it is, it's the sea surface temperature. So it's ocean temperature only. And what it's showing is the temperature anomaly. So how much hotter or colder the temperature is.
And this absorbs solar radiation.
Oh, this one is, this is the different one. Oh, okay. Well, actually, it still shows the same thing. Okay, there's another graph that looks just like it for the sea surface. But, and what it does, it's showing, in this case, absorbed solar radiation for a particular latitude. And so...
Over time.
What was that?
Over time.
Over time, right. So that over here is 2000 and up here is 2025. So it goes up to 2026. And what you see here, and so here is when you have El Niños and La Niñas, the absorbed solar radiation is changing. But something happened here starting around 2020, only in the northern oceans. And it increased solar radiation by a lot. And what happened around that time? That's when the ships started using cleaner fuel. And so it has less sulfur. And it had a huge impact. And this is sort of like a permanent, I mean, you see it in the sea surface temperature graph, it looks the same. And this looks like a permanent El Nino is formed, where the El Niños, La Niñas go back and forth here. This one is just continuing on. And so that's a really important graph. And then Jim Hansen wanted to show that 2026, his bet is that 2026 will be the warmest year ever. And then 2027 will be significantly warmer than that. But since 2024 was so warm, how could it be? Because look, if you see here, so far, 2026 has been cooler than 2024 every month, the average monthly global temperature. And so it has to go above and then stay significantly above for the rest of the year. And he's saying that's going to happen. July, he said, might not be much different because of the lag between El Nino sea surface temperatures and the global either ocean temperature. He said lags 1.5 months and the land temperature lags 3 months, but it's going to go up and be significant. And he has there's like a running bet with Zeke Hosfather, who says there's a 2/3 chance that 2024 will remain the warmest year this year, not next year. But so if this is 2024 though.
Oh, sorry, 2024 will remain the hottest. Yeah, I think, but he published something last week or this week, saying that Hansen and he are both right, because
he's going to pick different different temperature measurements. Yeah, but
it's a bit of a straw man,
that may not be true, because what if it's warmer across all of the measurements? Then Zeke would be wrong.
Yeah, but then of course he says,
but they'll say I still said there's a 1/3 chance that would happen anyway, so you can't lose.
And that it's super El Niños that caused it. But the problem, of course, is where did this heat come from? Right? You can have all these debates, and Personally, I don't think the question of which year will be the hottest globally on average is particularly interesting, right? It may happen, it may not happen. There's always variability, right? And you can argue until the year is up, and then you can say I was right or I was wrong, or if I would have known this, I would have been right anyways, right? Who cares? Who gives a damn, right? It's all the point is, if you look at the evidence, if you look at the observations, and if you look at the science, right? If you ask the meteorological organizations who they have taken an honest look at the data, the World Meteorological Organization, or the Germans, as I already pointed out, they say we're in a very big hole and we have to stop digging, and we have to take this very seriously, and we have to adapt. And then there's all these journalists and social media personalities who argue about these largely irrelevant things, I think, and who don't really read the science, I think. And I'm not focusing on any individuals here, but it was the same with when our global warming in the pipeline paper came out. With all these strawman arguments about what global warming in the pipeline means, and they just said if it means this one thing, I think the paper is wrong. But they didn't even read the paper. They didn't even try to understand our definition of global warming in the pipeline, which is not instant net zero, instant human extinction scenario, and how much warming will there be. We took a real look at what are the current forcings, and if these forcings were to stabilize, which is of course also hypothetical, then we will see about 4 to 5 degrees Celsius of global warming. And if you let this forcing keep stable for millennia, you could see 10 degrees Celsius of global warming.
Right.
It's not hard to understand, but if you don't even read the paper and you say, if I just read the title and misrepresent what it means, they are wrong. Sure, right? And I think there's a lot of that happening. I don't think it's...
Yeah, the question is, like, you're supposed to publish either a letter saying we're pointing out the mistakes in the paper, or maybe you publish another paper where you, again, point out errors in the scientific method of the paper. But I'm not aware of anyone who's done that.
No, they just publish blogs and social media posts, and they sell their books over it rather than addressing the real science. They don't address the science. They don't.
Well, there was one comment I heard from a climate scientist said that the temperature in the ice age was not what Jim said. He got it from Tierney? No, not Tierney. The woman.
Yes. Yeah, Jessica Tierney.
Yeah, Jessica Tierney, right. And so then I looked that up, and in her paper, in the abstract, it said that's the temperature. She used the same temperature Jim used her temperature. Now, to be fair, she published other papers. She's looked at this multiple times. And in the past, she had different temperatures. But the most recent one was the one that Jim used. So that criticism was not valid as far as I can tell.
Yeah, and there was even one guy, and he was also a scientist, and he was quoted saying that we didn't take into account water vapor. Right? It's like
right. By the way, so let's just finish up with these graphs here. So Jim also put in this, which is very interesting, a very nice sort of basic thing to see what's going on, why temperatures are accelerating. And this dashed line are all greenhouse gases, so that's CO2, methane, etc. The red line, solid red line, is just CO2, and you can see how it's increasing over time. By the way, we're supposed to be cutting it; it should be decreasing, but it's but of course it's and then net forcing. Well, that's of course it's cumulative, so that's the other. And then this dotted blue line is aerosols or pollution. And you'll see it was growing at the same through 1975 at the same rate that the greenhouse gas forcing was increasing. So it was countering that increase, and up until around 1970, the global temperatures was not going up a lot. It was just kind of moving around. But starting in 1970, the temperature started going up in a kind of a straight line. And look what happened. We cut back on our pollution, so it didn't increase. Now it started to decrease a little bit. For a while, it was just kind of steady while the greenhouse gases increased. So therefore, we had increased global temperatures. And now it doesn't really show that 2020 a little bit, but the problem is it's not really a global number anyway. It's a regional number where cutting shipping emissions over the pristine ocean can have a much bigger impact.
You clearly see.
Say again?
It's not zoomed in, but I've shown the graphs here before. You see that the dip in 2025, it's lower than, or 2023, 2024, 2025 are lower than a few of the years before, right?
Oh, that's over here.
The aerosol forcing from Forster et al., which is, of course, completely ridiculous because this is assuming that these forest fires are man-made, but only for
I see.
for the aerosols.
So let's go on to the next one here. Go up here, click. And this is kind of the summary of all of it. This is the global average temperature. And you can see through 1940s to 1970s, kind of steady temperature. And then we stopped increasing aerosols and the temperature started going up. And something happened around 2020 where it dipped a bit for a La Nina. But what's really interesting is, when you have a La Nina, it should be below the trend line. And when you have an El Nino, it should be above the trend line. And like, here's an example. Here's an example of the super El Nino, the 1998, is it there? And then the La Nina was below the trend line. But this year, after 2020, the La Nina years were on the trend line, which meant the trend line wasn't the trend line anymore. And in fact, something had happened to increase the trend, and it doubled in the rate of warming since 2015, I think it was the break year they used. But and here we see years above the 1.5 target, and then with a La Nina, it went below, but again, still on the trend line, which is a little scary thing. When you see a La Nina, it's on the trend line because it means your trend line is even higher than you think. And these coming 2 years are going to be super hot. Maybe tied here, and then the next year going to be maybe above this graph actually, which is kind of crazy. We have to extend the y-axis this pretty soon. So this actually shows a lot happening, and it really does show. Climate scientists like to say, well, you can't tell in a short amount of time. It goes up and down. Yeah, it does go up and down, but the down part, the La Nina down part, is way above the trend, and so you have to explain it some other way. And the way you can explain it is that something fundamental has changed, and that is we've decreased aerosol cooling by a significant.
And I think that's two things here. I think what's important to look at is also the linear fit and the numbers behind it. It says from 1970 to 2010 it was 0.18 degrees Celsius per decade, and from 2015 to present it was 0.4 degrees Celsius per decade, right? So more than a doubling of warming. And then again, indeed, you mentioned some skeptics saying certain things, and so, like a particular loud voice had been saying there was no acceleration, and that you cannot look at El Nino. And then he publishes a paper about saying this is in line with the models, and it's just a normal El Nino. But he doesn't even mention the word rate of warming, while he's been saying that the truth is bad enough about the rate of warming increasing for 5 years, right? So it's I'm sorry to say, but it is really disingenuous. I cannot see it any other way.
Okay, so that is the slides I had. So I have to make a point that Jim was trying to make with all of this. And that is, while El Nino is an important thing for the increasing the temperature temporarily, and then La Nina for cooling it temporarily, the reason it's so high right now is not because of El Nino, but because climate sensitivity is higher than we thought. And therefore, cooling from aerosols is more than we thought. So when we decrease aerosols, we get a bigger jump in temperature than we thought we were going to have. And that's why we might, well, almost certainly going to have 1.7 degrees global average temperature or more in 2027. Yes, the super El Nino is going to push it up there, but the reason it's even close to that is not because of the El Nino, but because of the bump in temperatures from decreased aerosols. And so anyway, so that's the main point that we're trying to make.
And greenhouse gas forcing, of course, which everyone here knows, but it's always important to keep mentioning that the warming is because of the greenhouse gas, and the aerosols were hiding the warming from greenhouse gases.
Right. Mm-hmm.
So more so regionally.
With that, let's see if Stacy, are you ready to join us? And then, or I don't see your camera on yet. Up there we go.
Maybe
so
she's herding her cats.
Let's see if let's see if the cats are there. Up there they are. Okay.
Just Rocky. Poppy has chosen the bed today, so
okay.
Yeah.
So, what are your thoughts? Any questions on what we were talking about there?
Well, I had some thoughts of my own first. One was, I can't believe you are now just reading Ministry of the Future, but I'm glad you finally caught up. And let me know if you have a hotline to the Children of Kali, because I've been wanting to sign up.
No, so I read it a long time ago, and I have to say I was very frustrated with it, but it was only me because he's doing a really good job in this fictional book of explaining real climate science all along the way. You probably got the same feeling, Leon. And since I already knew all of that climate science, it was like, okay, get to the story, rather than explaining this, that, and the. I mean, I was glad he did, because obviously it was really meant for other people, to teach them. But it was very frustrating for me because I knew it all, and I wanted to get to the story part rather than just the explanation of greenhouse gases and these kinds of things. But it was,
what I agree. It's, and as someone else said, I couldn't get into the book, and I think it's. I would love to have the author on Climate Chat as well. I think I'll ask him. But of course, you have the start of the book and start, so I can talk a bit about it. We won't spoil too much. Is where a big disaster or heat wave happens, and millions and millions of people die in India. So I think that's really a shock that wakes up at least that part of the world into action, and also other parts of the world. And then they found this. They find this Ministry of the Future to try to fix the problem of today, or I think that's 2030 or so, when they start really to work on it. And then what I found really even more shocking, although I of course also know much about it, is where he writes about these scientists and all these experts having this conversation, and someone is taking notes, and it's really like not detailed. And that's like, I've been in many meetings like this, right? And it's like, and he writes about things, how bad they are about 10, 15, 20 years in the future, but it's like we're already there, right? It's already, we're facing so much already what a fictional book wrote about, and it was published in 2020. I think 2020. So it's only 6 years ago, and it's gotten so much worse already in 6 years. It's hard to grasp how fast it's really going.
And there was this French meteorologist who, back in 2014, published a pretend forecast for the year 2050, and told where the temperatures would be around France, and had this map. And then this year, in June, the actual forecast was worse than the 2050 forecast that was made up to show how bad things will be in the future. And it happened in 12 years later. Yeah.
So 25 years or 24 years early and worse.
Say again? What was that?
24 years early. So 2050
Oh, yeah,
minus
24,
26 is 24. So 24 years early, and it is even worse than this fake forecast.
Okay, so Stacey, any question? We'll get to Eli.
Well, the other one is that I saw the comments. Some writer said that Britain should embrace the Mediterranean climate that's coming, and Leon posted about, oh yes, Netherlands, we should embrace the underwater living.
We should embrace living on the water.
Yeah.
We cannot stop climate change. We should embrace living on the water. I think that's what I wrote.
Yeah.
It's a little bit of like let them eat cake.
Yes. Well, and to say nothing of your grandchildren once the AMOC has shut down, they will be popsicles. So
yeah, England's really screwed. By the way, I mean, in terms of one paper, it was about AMOC shutdown. They would lose 70% of their arable land. Yeah. So. By the way, I didn't mention it at all, but please like and subscribe, everyone. Yes. It's free. Hit the notification bell. Leave a comment. We're trying to reach more people with this. It's kind of detailed climate science, so it's it's not a cat video, and so it's not going to reach quite as many people. But you can help us reach more people by liking and subscribing and hitting the notification bell and leaving a comment. And it's all free, and it helps a lot. What was that?
And share this video.
And share the video.
Yes.
Very good. Okay.
And so my question, Leon, it's somewhat related here, but it's, you've studied the shipping. Well, yesterday or Friday, I guess it was, I rode the ferry between Oakland and San Francisco, which I don't do that often. And I was in shock at the empty container berths. I've never seen it like that before. I didn't have the opportunity to do that during COVID, so I don't know what it was like then. But in any other year, and I've been here 25, I cannot remember seeing that empty of all these places where there are normally this, whole palette, of colors of containers, and they're just empty. And so it made me think, oh yeah, tariffs, and that thing.
Why Trump is the greenest president we've had.
So have you been tracking? Has shipping been down since the U.S. is the largest importer on Earth? And we have our amazing
I don't know,
tariffs.
It's a bit anecdotal, of course, but I don't follow the ship. I do follow some people on X who post about it once in a while, and of course you had the blocking of the shipping in Hormuz, and how ships had to go around around Africa during the war/genocide in Palestine, right? In Gaza and Israel, whatever you call it. So there's all these shocks happening at different places around the world, and that has impacts on shipping, on emissions, on many different things, and it's hard to keep track. I think and that's all. That's also the honest answer. If you look at some of the science, for example, they saw the increase in cloud forming around Africa when these ships avoided the Suez Canal during these wars, right? So you can see it sometimes. I haven't really looked into the tariffs and what that did with shipping around the world, or between North America and China, for example. But it's interesting. Sure. You could look at it.
Yeah.
Okay.
And so
So-
maybe go to Eli, and I have
Okay.
a whole host of
And then we'll get to the YouTube.
questions.
So if you're listening live on YouTube, you can leave a question and preface it with question so that we can easily spot it. Okay, let's get Eli here. And Eli, welcome.
Thank you, Dan. So 3 points I'd like Leon to respond to the last two. The first one is we're experiencing climate change, and that means more wildfires, not just this year, but probably every year. And adaptation means figuring out how to be damaged as little as possible by that. And so masks were mentioned, and it's not just masks, but it's high quality respirators that are necessary, like the blue medical masks with
right.
gaps on the sides. That it's better than nothing. It reduces it 70%, but it still lets plenty through, and that's why people said masks don't work preventing COVID, because 30% of a dose of COVID still gets, if SARS-CoV-2 still gives you COVID. But the N95 masks now, they are widely available. They're cheap if you get them in bulk. I got 440 for 14 cents each of N95s, and they do a lot better job, not only on the PM 2.5, but PM 2.5 means
Particulate
2.5
matter
microns.
2.5
Here we go.
micron.
These are the N95. That's what they look like. They don't look like the hospital ones that you get.
Well, that looks like a KN95 with the ear loops, but
Yeah.
which also is much better than the medical masks. But there are lots of different forms for different faces, and it's an investment in your health, honestly, whether it's viruses or smoke.
Okay.
Which are both aerosols, to be clear.
Yeah.
And I think that's, and I said it before, but really that was also gross negligence by much of the scientific medical community, by that they've been denying or keeping quiet that there was these viruses were aerosols. Well, the aerosol community knew it all along.
Yes.
Okay.
So
yeah, what's your other point?
Second point out of 3. If you looked at a number of the graphs that you had up, the inflection point really seemed to be like around 2008. What happened in 2008? That was the start of the fracking boom, and which meant both methane being released and less coal being burnt. Now in the United States, the coal was burnt in plants with scrubbers, so we didn't see as much of an sulfate aerosol reduction in that, but probably a little. So all of these things combined together, and we're doing exactly the wrong things, unfortunately. So, and then the third
For the right
point,
reason, for something.
the third point relates to this super El Nino. It's being compared possibly to the 1861 El Nino, which had much of the Central Valley of California being a lake. And that is actually a 200-year cycle, plus or minus 40 years. So we could be due for it, which had been attributed to variations in the solar cycle, right? But what we're doing with Earth energy imbalance is much larger than the change in that solar cycle that drove that super El Nino. And so
was that a strong? Was that a positive cycle? Was that a peak of the cycle? More sunlight?
it was a minimum of the sunspots, so it was a peak of the radiation.
Minimum.
Okay.
And so we're doing more than that with Earth energy imbalance. And the thing with El Nino, in Jim Hansen's last communication, he's saying it's not El Nino, it's climate sensitivity, equilibrium climate sensitivity.
The trend, yeah.
And yes and no in the following sense. El Nino, at least as best we understand it, is a charge discharge model where heat accumulates in the ocean and charges up, and then you have an El Nino that releases that heat. into the atmosphere.
But even during, don't need a question yet, but so even during this El Nino or the last El Nino, which 2023, 2024, there was more heat accumulation than released. So even with all these record global temperatures, the Earth's energy imbalance, so the rate of heat accumulation, was still positive, while there was, of course, much more outgoing heat radiation because of these high temperatures. So you're right. There's this battery. It's like it's decharging while you're charging it.
Yeah.
While you're still charging it, right? So you keep charging the battery and you take some out, but I don't know how. I think we should be able to talk about watts. It's like if you charge it with a kilowatt and you only take out 500 watts, you're still charging it with 500 watts, right?
Yeah.
And that's more or less what's been happening now and that's some of the skeptical scientists were surprised by that, saying, okay, wow, if you see the science, even during an El Nino, we see ocean heat content increase still. And that was, while of course the ocean heat is released by this El Nino.
And so the point that I'm making is kind of it's in the direction that Hansen was making, but it's kind of stating it in the opposite way, in that we see the global warming when it discharges as an El Nino.
Yeah, you see the peaks. I think that's the whole point. You see the peak of the trend, right? You see the trend. I think Dan explained it very clearly. He showed the different trend lines, and then you see these years, and you see that even the La Nina years, the dips are above the new trend line even, right? So, yeah, the trend is the acceleration, and even the World Meteorological Organization shows that in their most recent publication on ocean heat content. The rate of ocean heat content increase is increasing. A second order derivative. So it's like it's not just increasing, but it's increasing faster.
Yeah.
Okay.
The increase is increasing.
All right. So, Stacy, do you have some?
Oh, I have a lot of good ones.
Okay, you can give me the
so-
timestamp. I can see if I can get it.
1050. Are you able to reach that, or is it just the
1050? I
past?
can. Yeah, that's after I can go back.
This is one of our favorites. It's Peter Sarvos, and he said, net, would you say President Trump has done more to accelerate the global growth of renewable energy than anything else we've done in the last 5 years? I'm being serious.
Yeah. I mean, what should we do? We should increase the price of fossil fuels. That's number one thing you should do. I call for a carbon tax, which is a way better way of doing it than what he did. You want to, and you also want to destroy the economy, right? Because the economy is what drives emissions. And so, if you do those two things, and he's not trying to do either of these things, by the way. But
who blew up the Nord Stream pipelines?
Oh, that's true. Isn't that Biden? Was that no? Or was that Trump? I don't even remember. When did that happen?
Biden.
It was Biden,
right?
But no. So there's. Biden did, the problem with both Obama and Biden, they both did things to try to fight climate change while at the same time increasing fossil fuel extraction as much as humanly possible and being proud of it, right? So that doesn't work. Now, Trump's trying to do exactly, he's trying to increase fossil fuels, but he's less competent at doing it. So he's actually he's stopping some wind projects and trying to stop solar projects. It's really hard to stop them because they're economical, right?
Especially when they are in view of his resorts or something, right?
Well, by the way, Democrats have done that too. The Kennedys were famous for trying to stop offshore wind off of Massachusetts. But anyway, so he's done these bad things, but globally, he's raised fuel prices a lot around the world. And it's done two things. One is because it's a higher price, it's driven other countries to seek out renewable energy because it's cheaper. But they also saw by closing the Strait of Hormuz, you can get screwed very quickly because somebody decides to have a little war over there, and it screws up everybody. So they realize not just for economic reasons, but for national security reasons, you shouldn't be dependent on fossil fuels. Now, they should have learned that from Russia and Ukraine and all that. And they should have learned it a million times over by now. But
That's what Pakistan did, right?
yeah. So anyway, so for these two reasons, countries have rededicated or increased their efforts to switch over to renewable energy. Plus, even though it's not happening much in the United States, the switch to EVs is happening everywhere else. China's up at China, the largest car market in the world, bigger than the United States, is over 50% sales of EVs already. Norway's 97% or something like that.
Ethiopia is even higher.
Yeah, and everywhere. Mexico, where they don't have import tariffs for EVs. These Chinese EVs are really nice, and they're half the price of U.S.-made cars.
BYD, build your dreams. It's like
build your dreams. Yeah.
When I was in Addis Ababa, I saw because they have these, you cannot import fossil fuel cars anymore, and of course they import all the cars. Because they are very heavily dependent on fossil fuel imports, and they don't have fossil fuels of their own, but they do have a lot of hydro and sunlight, of course, and wind potential. So it's like really crazy. Within a few years, like all the cars are electric.
Okay. Let's go to the next. Let's go to the next question because it was.
So there were a couple on like global effects. This is a long time ago, 1015. Jean asked, any information specifically about heat and drought in the Middle East?
Going to get worse. Dry places tend to get drier. Wet places tend to get wetter, and just overall. But actually, I used to give these talks and climate talks in 2008, and I used NCAR's data for drought prediction in 2060, which is not that far off. Most of the United States was, I can't remember the numbers, but it was significantly higher drought than the Dust Bowl by a lot, and over most of the country. So, and then there were other parts of the world facing the same thing. So drought is a really big problem. And of course, at the same time you get drought, you get this very intense rain that's very destructive because it comes down all at once rather than being spread out. And so either one destroys your crops and destroys your town through flooding and things like that. And you can't build infrastructure that handles 10 inches of rain in 24 hours. I mean, 3 inches is a lot. That's a huge storm, and 10 is insane.
Like, how much is that? That's precious meters.
What was that?
I said, I don't know.
How much is a meter? I don't know.
But I think
2.5 for 25 centimeters. 25 centimeters.
Of rain?
In a day.
So that's 25 centimeters. That's 1 millimeter of rain on a square meter is a liter. So 25 centimeters is 250 liters, is 250 kilograms of water coming down within a day. Per square meter.
Per square meter. Yeah. That's a lot.
So that's like a cow weight of water per day per square meter. Light cow.
Wow.
So, all right.
And
I just want to answer also, like, I don't know, of course, the Middle East is a large region, right? It's, and I think if you want to, and I don't know what the time horizon was of the question. So if you want advice, please consult either the World Meteorological Organization or your regional meteorologists, because those knows best. You need to ask the regional experts to understand what's happening, and if they don't take into account, for example, these aerosol reductions, you need to tell them to do so.
Also, by the way, speaking of bad things happening in the future, is that the glaciers in the Himalayas, which provide water to, I think, over 2 billion people, it's melting. It's not. There's a lot there, so it's not melting right away like it has in other parts of the world already. These mountain glaciers have disappeared. That's a big one. And in the short run, as it melts, you get more water rather than less water because it's melting. But then when it's gone, and you're really screwed. So these are these are things we know. Like we don't know exactly when that's going to happen. We have rough ideas, and yet, boy, we're really able to put out of our mind future problems and focus on the minutia of what's happening now. Okay, what's next, Stacey?
eComquest wanted to ask Leon how the canals are holding out in the Netherlands.
I think they're very dry at the moment. We are the KNMI, the Dutch Meteorological Organization's measuring point in our town. So I think we had like 0.3 or 3 millimeters of rain in July. So there's a big drought going on.
And in Europe, the rivers are really low, and they're having trouble using them for shipping. Putting boats on them, tourist boats and freight boats and things that go down the river. It's a big problem.
Yeah.
Martin mentioned.
So I don't look at the canals often.
Martin mentioned that he feels that in Germany the clouds have changed, and Jean wanted to know what is the latest understanding of the effects of El Nino on clouds, specifically low clouds that feed the cloud forests near the equator.
I'm not an expert on that, but we had George Salutis on talking about overall as you warm the Earth, and we didn't know this, but he studied it to see what actually happened over the last 25 years of satellite data. That clouds, it turns out that clouds decrease as the Earth warms. They could have increased, but they decreased, and that's a feedback for warming, which is a positive or amplifying feedback. And this is one of the reasons that the climate sensitivity is 50% higher than the IPCC says. But they didn't have cloud feedbacks in there. And if you throw cloud feedbacks in there, that makes it a very powerful feedback. So it means as you warm up, you get less clouds, which makes it warmer. And so
you have what's called intertropical convergence zone, and then these rain bands can shift. And what this El Nino could impact, how this El Nino could impact a certain region of the globe, and how much. Again, please consult your regional meteorologist because they can. I think it's really crucial. These questions are really important. People need to prepare for their regional weather impacts over the coming years, but we don't know everything about every country on Earth. So you really need to ask the regional experts these questions. And then on the clouds, I think Martin is right. The clouds are changing. I've seen it as well. I'll ask my friend who has a PhD in clouds and microphysics and who looks at clouds every day, all the day. So, but I do think clouds are changing because of both the weather pattern changes and of the aerosol reduction. The most clear example of that, of course, was during COVID, when you didn't see the high cirrus clouds, which some call chemtrails, but are just cloud condensation. It's just cloud condensation because of these airplanes flying high and emitting particles and causing turbulence and emitting water vapor at high altitudes.
Okay.
About fires, this is 1024. I don't know if you can get to that. Peter was wondering if the climate models underestimated CO2 emissions from fires. They don't even really tackle it, do they? And then also the cooling, have they underestimated cooling from forest fires? What's that?
Sorry, cooling. Yeah, that's a good question. Yeah, so these CO2, the CO2 emitted is not part of the carbon budgets, or it's just natural. These forests will grow back, and then in the models that's not taken into account, and but the cooling of the forest fires, I don't know, like that's very regional and very time dependent, and where does the wind blow to, and the other the in the other way around, it's like the reduction, and there's some science on that. I don't know the name of the author by heart, but there's a publication showing that the reduction in air pollution, reduction in sulfur emissions, increases boreal fires because of changing weather patterns and because of less sunlight reflected back to space, so more drying of these forests. So, and that makes it very complex, of course. And you can put it into a simple model, but that doesn't change reality, because these ships, they sail over the ocean every day of the year, and then they keep emitting. So there's a constant cooling of the oceans, and then these forest fires are burning mainly in the summer, and then that, of course, then where does this wind blow?
Unless
It
it's
blows over
Australia.
Atlantic.
Well, I mean, I guess it's still their summer, but we get it year round.
Summer, it's the other hemisphere, yeah. So in Africa, I was in Africa to cool down, and some people, it was like 18 degrees Celsius, and some people were wearing like winter jackets and mittens and hats. It was really fun.
Yeah, that's the way it is often here in the Bay Area. In fact, I worry a lot about our complacency. We're, this is an area of the country that is very thoughtful about these things and would want to do more. And we do not do nearly enough for what we should. And I think a lot of it is because we don't feel the effects. Today is one of our hottest days, and it will be a high of 79 with 26 Celsius. That is what feels like, oh my gosh, it's really hot here, and so we don't get it. It's like just some sort of, oh, that thing happening over there. We don't internalize it and make the changes we should here. Another thing about fires.
Let's do one more.
Dalbert-
Let's just do
Oh,
one
sorry.
more question.
Oh,
and then
just one more? Oh my God.
Yeah, I mean, there's a lot, but
There's
there's a lot of
lot.
things I could
Okay.
comment on here that I'm just reading through.
Okay,
But
one that I thought very interesting, Nevitz at 1125, they want to know how the rate of invasive plant and insect species has been increasing across the planet over the last century.
well, insects are going down, which is a very dangerous
Well,
thing
here.
overall. But the
We have
invasive
we
ones,
have
I don't know.
Small ants who are like, and it's just one example, like, who we have to send by mail to these ecologists who look at what species of ant it is, and like they can dig below your house, and it can like make your house like shift and crack. And so of course there's globalization happening, so it's not just climate change causing species to move further north, further up the mountain, but it's also all these species having access to the rest of the world, which they didn't have before, and they will travel there through fruits or vegetables or ships or in people's backpacks, right? So, and there's many things happening to ecosystems, introduction of plants, and people releasing their pets which they don't want to take care of anymore, but they don't want to kill themselves or get killed by the veterinarian. They intrude into the ecosystem. So it's all of the above, right? That's happening to these ecosystems.
Well, and also in North America, we have the range of like moose shifting and deer shifting, and that means that ticks now are established in places that they weren't, and things like the Lone Star tick meat allergy and other tick-borne illnesses are in places where they never used to be.
So let's end on a somewhat good note, I would say, because this is a comment that someone said, oil is in every action we take, and no one has removed oil from their life by choice. If people are concerned, will they stop spending as much? Well, first of all, if you want to, and you're reasonably well off, you can buy an EV instead of a gas car. You can put solar on your roof. You can change your heating system to a heat pump and use inductive heating for your stove, which boils water in 30 seconds instead of minutes. So it's actually better all the way around. And also get an electric water heater instead of a gas water heater. You do those things for your home, and you will have gotten off of fossil fuels if, assuming you're getting your electricity from a clean source. If, again, your own solar panels, maybe a backup battery, or you're in a place like California where most of the electricity is from low carbon sources. So it is possible to do. And if you did all those things, you'd save a ton of money over time. Maybe spend a little more upfront to get those things. But let's say you're building a house, you put those in right up front, cost you a little bit more maybe for the heat pump rather than a regular heater, but you're going to save a ton of money over time. Heat pump is 500% efficient, which sounds like it's a perpetual motion machine, right, but it's not. And anyway, so the good news is we can switch away from fossil fuels, and we'll save trillions of dollars if we do it. Now, it is still hard to do for cement and steel. It's not impossible to do, but that's where fossil fuels really shine, are these what's called process heat, getting really hot temperatures in industrial applications. And there's ways to address that too if we got serious about it. And that's why I suggest, rather than promoting renewable energy, which just gives us more renewable energy, not less fossil fuel energy, instead, the policy should be to phase out fossil fuels. And that way, renewables will grow rapidly to replace the fossil fuels and won't just add to energy supply, as what's happening so far. So anyway, the good news is we actually can do it if we chose to. Now, so far we haven't chosen to, and it is still cheaper. And that's one thing that's going to drive the transition anyway. But if we do it that way, the fossil fuels will decrease very slowly over time as renewables get cheaper. But if you phase out fossil fuels, they'll decrease rapidly over time. And that's what we need. Plus other things we need, SRM and CDR and things. But we can address this. The future still is in our hands. But let's not pretend that we're really doing much about it right now. We're really not. But we could if we chose to. So that's what I want to end with. And Leon, any further comments?
Yeah, I think also the example of Ethiopia, which I already gave, is of course, for them, it was a big foreign exchange problem that they had to pay a lot of money to import the oil, and the exports weren't very high, so they lost a lot of the value of their own currency, because they had this big foreign exchange problem. That was one of the important reasons why they banned fossil fuel cars, and so. And there's many countries like that, and we already talked about it quite a bit, about all these incentives to move from fossil fuels to more available and more sustainable power sources. And I think we should also talk about nuclear, and I think we already are planning to have a guest on, and we should get onto that as well to talk about that in more detail, because I think that's
okay.
It's often a subject that some people are very emotional about, but I think the basic physics of E equals mc squared is beautiful, and we should use it to our advantage instead of
for next week. We'll do that on next week's show.
Maybe we should do the continue, like, ask me anything kind of thing next week or something. But
yeah, we can debate nuclear versus renewables.
Oh yeah, we're going to debate nuclear. Yeah. There's been a lot of discussion, but I've been going back and forth on Twitter on that one. The bottom line is that nuclear is safer than coal by at least a factor of 1,000 by any metric you want to use, including deaths per kilowatt hour generated, even including Chernobyl and Fukushima and all of those.
Yeah, that one death that can be attributed to Fukushima is indeed, you have to take that into account. You have to mention it.
Right, but even if you assume tens of thousands from Chernobyl, remember 8 million people are dying every year from fossil fuels. So it's really hard to, that's what everyone's worried about, is some mass casualty event that might happen with nuclear. Maybe it'll kill 100,000 people, if you have the worst case thing. We're doing 8 million every single year, and no one even talks about it. Not even like a mention of it anywhere, which is really kind of mind-blowing about that, right? So I always say that people care a lot more, care more about how they die than if they die. And so you don't want to die in an airplane crash, though driving a car is like 1,000 times more dangerous than flying in an airplane. And things like that. So we psychologically are really scared about certain kinds of dying, but die from fossil fuel pollution, and you're scattered around the world where no one knows it was actually you that died from fossil fuels. That's okay.
So people are scared of hypothetical deaths. It's really strange.
Well, also nuclear. They're really worried about dying from nuclear.
Yeah, it's also hypothetical, right? It's not. Yeah. There's like this. Nobody's dying for it, right? It's the lowest energy death source.
I think it's even less than solar, someone said, but I don't know.
Exactly. Yeah. So it's like nobody is dying. Like nobody.
Go get your data and bring it back next week.
There's data.
And it's the old story that if it's on the news, you don't have to worry about it.
Rational conversation, right? I can have a rational conversation about everything, but if you want to have a dogmatic, like dogma versus dogma, it's like, and then they say I am pro-nuclear or something because I present facts related to nuclear power. It's like you cannot win an argument with someone who's really dogmatic about something.
Well, we've gone on for an hour and 50 minutes. I think that's enough for a pretty long show. Yeah. We sometimes have these really long ones, although we've been trying to keep it closer to an hour, especially when we have a guest on. But thanks everyone for joining us again. Please like and subscribe, hit the notification bell, share the video, leave a comment. All of these things help with the YouTube algorithm that will then therefore show this program to more and more people. Again, we have a very small base compared to most other programs on YouTube on different subjects that,
Mr. Beast.
It is kind of weird that the most important subject gets sort of the least views, but that's part of the problem we're facing here. So we're trying to spread the word. You can help us do that by, again, liking the video, subscribing to the channel, hit the notification bell, leave a comment, and share the video. These are all free things you can do. Helps us, and it helps everyone because it gets the word out more.
And sign the letter to the warning letter on El Nino, please.
Search for yellow dot. Is it yellow.org or yellow.studio?
Put it in the show notes or the comments
we can do that later,
after the show posts.
Yeah,
we will.
Very good, everyone. Thanks, and we will see you next time.
Bye-bye.
Bye, everyone.
Bye.